Slicing of a NumPy 2D array, or how do I extract an MXM submatrix from an NXN array, n greater than n? I want to slice a NumPy NXN array. I want to extract an arbitrary selection of m rows and columns of that array, i.e. without any pattern in the numbers of rows/columns, making it a new MXM array. For this example, let us say the array is 4 by 4 and I want to extract a 2 by 2 array from it. Here is our array. The line and columns to remove are the same. The easiest case is when I want to extract a 2 by 2 submatrix that is at the beginning or at the end, i.e. But what if I need to remove another mixture of rows/columns? What if I need to remove the first and third lines/rows, thus extracting the submatrix 5,7, 13,15? There can be any composition of rows/lines. I read somewhere that I just need to index my array using arrays/lists of indices for both rows and columns, but that doesn't seem to work. I found one way, which is First issue with this is that it is hardly readable, although I can live with that. If someone has a better solution, I'd certainly like to hear it. Other thing is I read on a forum that indexing arrays with arrays forces NumPy to make a copy of the desired array. Thus when treating with large arrays this could become a problem. Why is that so? How does this mechanism work?
As Sven mentioned, x0, 2, 1, 3 will give back the 0 and 2 rows that match with the 1 and 3 columns, while x0, 2, 1, 3 will return the values x0, 1 and x2, 3 in an array. There is a helpful function for doing the first example I gave, numpy.9_. You can do the same thing as my first example with xnumpy.9_0, 2, 1, 3. This can save you from having to enter in all of those extra brackets.
To answer this question, we have to look at how indexing a multidimensional array works in NumPy. Let's first say you have the array x from your question. The buffer assigned to x will contain 16 ascending integers from 0 to 15. If you access one element, say xi, j, NumPy has to figure out the memory location of this element relative to the beginning of the buffer. This is done by calculating in effect ix.shape1 plus j, and multiplying with the size of an int to get an actual memory offset. If you extract a subarray by basic slicing like y equals x0, 2, 0, 2, the resulting object will share the underlying buffer with x. But what happens if you access yi, j? NumPy can't use iy.shape1 plus j to calculate the offset into the array, because the data belonging to y is not consecutive in memory. NumPy solves this problem by introducing strides. When calculating the memory offset for accessing xi, j, what is actually calculated is ix.strides0 plus jx.strides1, and this already includes the factor for the size of an int. When y is extracted like above, NumPy does not create a new buffer, but it does create a new array object referencing the same buffer, otherwise y would just be equal to x. The new array object will have a different shape than x and maybe a different starting offset into the buffer, but will share the strides with x, in this case at least. This way, computing the memory offset for yi, j, will yield the correct result. But what should NumPy do for something like z equals x1, 3? The strides mechanism won't allow correct indexing if the original buffer is used for z. NumPy theoretically could add some more sophisticated mechanism than the strides, but this would make element access relatively expensive, somehow defying the whole idea of an array. In addition, a view wouldn't be a really lightweight object anymore. This is covered in depth in the NumPy documentation on indexing. Oh, and nearly forgot about your actual question. Here is how to make the indexing with multiple lists work as expected. This is because the index arrays are broadcasted to a common shape. Of course, for this particular example, you can also make do with basic slicing.
I don't think that x1, 3 column 1, 3 is hardly readable. If you want to be more clear on your intent, you can do. I am not an expert in slicing, but typically, if you try to slice into an array and the values are continuous, you get back a view where the stride value is changed. For example, in your inputs 33 and 34, although you get a 2 by 2 array, the stride is 4. Thus, when you index the next row, the pointer moves to the correct position in memory. Clearly, this mechanism doesn't carry well into the case of an array of indices. Hence, NumPy will have to make the copy. After all, many other matrix math function relies on size, stride and continuous memory allocation.
If you want to skip every other row and every other column, then you can do it with basic slicing. This returns a view, not a copy of your array. While z equals x1, 3, column 1, 3, uses advanced indexing and thus returns a copy. Note that x is unchanged. If you wish to select arbitrary rows and columns, then you can't use basic slicing. You'll have to use advanced indexing, using something like x rows, columns, where rows and columns are sequences. This of course is going to give you a copy, not a view, of your original array. This is as one should expect, since a NumPy array uses contiguous memory, with constant strides, and there would be no way to generate a view with arbitrary rows and columns, since that would require non-constant strides.
If you want to see more, please consider subscribing.